So now we're going to talk about going from moles to the mass, which is going to be measured in grams, and we have to use the molar mass to find that, and it's also called the gram formula mass. And all that means is it's the mass of 1 mole of an element or a compound. And we can just find this on the periodic table. It's the atomic mass. So if I look up Na on the periodic table, I see it's 23 grams per mole. If I look up chlorine on the periodic table, it's 35.5 grams per mole. Okay, so that's how you look up the elements. With the compounds, you have to kind of break it apart and add them together. So let's look at water. We have 2 H's, and each H has an atomic mass of 1. So I have 1 times 2, and that gives me 2. Then I take the oxygen piece, and that's 16, and there's only one of those. And then I add that together. So I have 2 and 16. So water has a molar mass of 18 grams per mole. Okay, so now let's try one that's pretty complicated. We have ammonium sulfate. The first thing I want to do is list all of my elements that are in there. So nitrogen weighs 14, and we use the parentheses just like we do in math, so that 2 on the outside counts for that nitrogen. So there's 2 of those, and so we have 28. On hydrogen, there's it's an atomic mass of 1, but we have 2 sets of 4, which is 8. Sulfur, we have 32.1. And oxygen, we have 16, and there's 4 of those, so I get 64. All I have to do now that I've figured all that out is just add them up, and I get 132.1 grams per mole. That's how you find the molar mass. So we're going to move on and look at how we can use this. So it says calculate the mass of 0.25 moles of oxygen gas, which is O2. Okay, so I take my known, I write it down. I need moles on the bottom so it'll cancel, and grams on top. 1 always goes with moles, and for grams I need to take the oxygen, and there's 2 of them, so each oxygen is 16, and I multiply that by 2, so I get 32. Now my moles cancel. I'm going to multiply across the top, and I get 8 grams. Okay, let's look at another problem. How many moles of magnesium nitrate are in 38.5 grams of MgNO3 So I take my known from the problem. I need grams on the bottom so it'll cancel, and moles on top. So if I add up Mg, N, and O, and there's 2 N's and 6 O's, I'm going to get 148.3, and that 1 always goes with the mole. So my grams are going to cancel, and I get 0.260 moles. How many grams of oxygen are in 1.88 moles of magnesium nitrate, which is the same substance we just worked with? So I take my known, 1.88, I need moles on the bottom so it'll cancel, and now I'm going to go to moles of oxygen. So we talked about this a little bit in the last video. There's 2 sets of 3 oxygen, so there's 6 oxygen for every mole of magnesium nitrate. So my moles cancel there, but I want grams, so I'm going to do another step. For every mole of oxygen, now I'm just doing 1 oxygen, so it's 16 grams. So now where I want to be, and I multiply across the top and divide on the bottom, and I get 180.5 grams of oxygen. Let's look at another problem. What is the mass of 2.9 moles of sodium? So I use my known. Moles goes on the bottom, and 23 is sodium on the periodic table. Those cancel out, so I'm going to get one where I need to be. I get 66.7 grams. Okay, how many moles of water are in 35 grams of water? I have 35 grams. That's my known I start with. Grams needs to go on the bottom. Moles on top. Remember, we added up water on that first slide, so 18 grams was water. I'm going to cancel out my grams. I multiply across the top, divide on the bottom, and I get 1.94 moles. Okay, calculate the number of grams in 4.59 times 10 to the negative 4th moles of ammonium sulfate. So I write my known. Moles has to go on the bottom, grams on top, and this is the compound we figured out on the first page, so I'm not going to go through that again. We just have 132.1 grams. My moles are going to cancel, multiply across the top, and divide on the bottom, and I get 0.0606 grams.